Okay. Okay. Bill, YouTube goes away now while we have a lesson, please. So we're gonna talk about two other types of energy again today. We did all kinds of different ones yesterday. Took a little quiz on it. Those were just like types of energy. The ones that we're gonna talk about now are a little bit different. So I'm gonna share my screen. We're gonna do go over the PowerPoint. There's a couple of videos in them that we'll watch, and then there is an activity for you guys to do at the end that is going to be graded. So I want you guys to pay attention during this PowerPoint because you're going to need to use it to do that lesson at the end. The PowerPoint is up on Schoology, and it's attached to the Google Classroom assignment that I'm giving you, so you won't need to like write all these notes down. You have access to the PowerPoint. Sound good? All right. Okay, I'm going to pull it up on my end, and we'll get going on it. All right, you guys see my screen?
Yeah.
Yep. Okay. So, we are going to be talking about two types of energy today. One is called potential energy, and the other is called kinetic energy.
Like kinetic sand?
Kind of similar to, yeah. It's not like the same thing. So don't think about kinetic sand when you're thinking about kinetic energy, but it's the same word, yes. But they're not the same. Okay. All right. So today's objectives, we're going to talk about being able to compare and contrast, which is what you're going to do at the end, the different types of energy. So potential energy versus kinetic energy. Okay. And you should be able to answer the questions, what is kinetic energy and how is it different from potential energy by the time we're done with this and you've done the little assignment at the end. Okay, so that's what the hopeful outcome of this is. So let's talk about kinetic energy first. We have a snowboarder on the right side of our screen over here. This guy is moving, obviously. If you're snowboarding, you're going to be moving. Big deal with kinetic energy, the movement of things. So kinetic energy means that an object has energy because it's moving. So anytime anything is moving, it has kinetic energy. If you move your arm, it has kinetic energy. If you write with your pencil, there's kinetic energy happening. So anytime there's any form of movement, it's kinetic energy. Does that make a little bit of sense?
Sometimes at night, like my hand, like when I like rub it against my pillow really fast, it makes spark. Is that kinetic energy?
It's gonna be it's a combination of two energies. So that's kinetic energy, yes, because you're moving, right? But it's also thermal energy because you're creating some heat as well.
Even when you like have socks on and you slide them across the floor and then you touch something.
Yeah, so when you're doing that, you have kinetic energy because you're moving. Your feet are moving, but it's going to be different than the thermal energy, which is the heat that is being given off. Does that make sense? The difference?
Does food and water give us kinetic energy?
Does what?
If we didn't have those things, we wouldn't be able to move.
Does water give you kinetic energy?
And food?
No, that's a different type of energy, like calorie energy.
Because we wouldn't be able to.
Yeah, I agree. We wouldn't be able to do things if we didn't have water or food. But the energy you get from water or food is different than the kinetic energy that you put out when you're moving. Okay? So our next little bullet point there. So energy due to motion. Maybe I should just click through these before I start talking. Energy is due to motion. The amount of kinetic energy that an object has depends on how fast it's going and how much it weighs. So this snowboarder, if it's going kind of slow and it's a kid, like maybe like a 5-year-old is snowboarding and it's not moving too fast, he's not going to have a lot of kinetic energy. But if it's a full-grown adult and they're like bombing down the mountain, they're going to have a lot of kinetic energy because they're moving quickly and they weigh more. Okay?
What does kinetic energy do?
It's just measured by the amount of like energy you're giving off. It doesn't do a whole lot. It's just a type of energy.
What about me?
Go ahead.
What about me versus other rollerbladers my age?
It depends on the speed probably, and the differences
I'm like
in the
a
weight.
pro compared to my age, like, because I can go really fast and go up and down lots of ramps, and other people can like barely even go.
Then you would have more. If you're going faster and you weigh about the same amount, then you have more kinetic energy than they do in that moment.
I go faster than other people, like trying to go fast when I'm not even trying to go fast on rollerblades.
That's good. All right, let's keep going. The next part, I'm going to do the whole slide instead before I start talking about it. So here's an example. So the faster an object moves, the more kinetic energy it has. So a carpenter is using a hammer to nail in a nail to a piece of wood. So on the bottom left here in this blue box, we have when the carpenter swings slowly, the hammer has just a small amount of kinetic energy, so it doesn't really have enough energy to move the nail very much. So Dylan, that kind of answers your question of what kinetic energy does. If you don't have enough kinetic energy, you can't complete the motion you're trying to do. Okay? So if for the right side, this blue box over here, when the carpenter swings the hammer quickly, it has more kinetic energy, so it's able to move the nail into the wood with just one hit like it's supposed to. So let's say we were to throw a football. So I have a football in my hand. If I want to throw it super far, is it going to be better if I just like barely move my arm or if I really like move my arm quick?
What about when we're trying to do a flip? Do we need kinetic
You have to
energy?
really move your arm.
Hang on, we got 2 questions going there. Let's answer my question first and then we'll do your question. Okay, Charlie?
Okay.
Yeah.
So if I'm throwing the football and if I like barely move my arm and it's not going quick, is it going to go far?
No.
No, so it does not have a lot of kinetic energy. It's not going to go very far. But if I like bring my arm back and I throw it super hard and I go super fast, will that have a lot of kinetic energy?
Yeah.
Yep, definitely will. It'll go farther and get closer to where I want it to go. Okay, Charlie, what was your question?
What about when like someone's doing a flip? Do you need kinetic energy to do a flip?
Yes, definitely. If you don't have enough kinetic energy, you're not going to finish the flip and you're going to hurt yourself. So you got
That's
to
what
have
I did in Holbrook.
Yeah, so you got to have enough kinetic energy to finish the flip so that you don't like land on your head or something like that.
I can't even do
Landed on my back.
trampoline.
I got the wind knocked out of me.
Yeah, you needed more kinetic energy then. All right, let's go ahead and go on to the next slide. Okay, well, we'll start here. So the mass, which means the weight of something will also affect the kinetic energy. So the more weight or the more mass that an object has, the more kinetic energy it has. So if I try to throw a football, which is full of air, right? And I put the same amount of force behind it when I'm throwing it as I try to put behind a 10-pound bowling ball, which one's going to go farther?
Whichever one you have more kinetic energy.
That's true. But if the mass and how much they weigh affect it, so if I have a football that's maybe 2 pounds, and then I have a bowling ball that's 10 pounds, and I put the same amount of energy behind my throw, which one's going to go farther?
I know the football is, but like we're talking about kinetic energy, so I just want to say that. But I also want to say like that the football will win.
It will.
Ball.
Yeah. The football will because it weighs less, right? So let's look at the example it says here. It says, a rolling beach ball has kinetic energy. If the beach ball hits a sand castle, it might knock down a castle wall. And a beach ball just has air in it, right? Not a whole lot in it. Then it says, a basketball has more mass than a beach ball. It's going to weigh more. What would happen if a basketball rolling at the same speed as the beach ball hit the sand castle?
It would destroy the whole thing.
Yeah, it would destroy the whole thing. It's going faster, and it has, well, it's going at the same speed, but it has more mass, so it's going to hit it and have more energy that transfers into the sandcastle and knocks it
It's
over.
just gonna like break the whole thing, but like if it was like a beach balls are kind of light, so it, like if you hit it on top of it, if like the top of it is kind of pointy and small, it'll just make it like break a little bit.
Exactly.
Not
So
like a
Which
lot of it,
Jones
like
that
the,
thing's not letting me type.
not like
You
a
don't
lot
have
of
to
it,
type
like
it.
the basketball
I'm just trying to type so I don't have to do it later.
with
Well,
the
wait until we do it later so you don't do it wrong earlier.
Oh, okay.
Okay. So there's some stuff about kinetic energy. There's some more. Here we go. Kinetic energy can change into different forms of energy. So a windmill changes the kinetic energy of wind into electric energy. So it's taking the energy that makes the windmill move of the wind and it's changing it into electrical energy so that it goes to like the lights and stuff like that. Okay?
Whoa.
Right? And then if we think about someone playing the drums, the drumstick that they have hits the drum, and that's kinetic energy, using your kinetic energy to make it hit the drum. But the stuff that comes out of it is sound waves or sound energy instead. So sometimes kinetic energy can change into different forms of energy, which is pretty cool.
I know what happens.
What?
Since it's like the smallest cells and like something can go through cells, like the energy just bounces around inside of it to make it kind of like louder on the sides, and sometimes it goes throughout, like it mostly goes out the other stuff.
Mm-hmm.
Miss
Yeah.
Jones, I don't get it.
So it
I
just,
don't
like,
get
noise
drums because
throughout.
why do they have the bottom piece for?
On drums?
Yeah.
I
For the,
have no
for
idea.
the
I don't know a lot about music, so you're gonna have to look that one up.
they have the bottom part of the drums to like help the drums like let the sound like bounce through it. Well, let the energy bounce through it, and then it turns into sound, and then it comes to our ears, and then it comes to our brain, and then it helps us hear the noise.
Whoa.
Yeah, basically what he said. Okay, here we're gonna go ahead and mute your mics. We're gonna watch a video on Brain Pop that just talks about kinetic energy. It's pretty short, but this might give you a decent overview as well of kinetic energy. So go ahead and mute your mics, and I'll play it on my end. Are you guys ready?
Mm-hmm.
Okay.
I don't know the instruments either, but I just guessed.
That sounds pretty good. I think that you're on the right track. I can look it up later though, and we'll find out.
Okay.
All right, go ahead and mute your mics. Let's go ahead and watch the video. Here we go.
Dear Tim and Moby, why is kinetic energy important? From Melissa. Well, energy lets us do everything from running a mile to typing on a computer. When an object has energy, it has the ability to cause change. Kinetic energy and potential energy are the two types of energy that relate to motion. Potential energy is stored energy that increases or decreases depending upon an object's position and condition. Moby and I store up more potential energy the higher we go on the ski lift. Kinetic energy is the energy that an object has because of its motion. If it isn't moving, it doesn't have kinetic energy. Right about now, our potential energy is being transferred into kinetic energy. The amount of kinetic energy that an object has depends on its mass and speed. A fast-moving object with a lot of mass will have a lot of kinetic energy. Moby and that snow tractor are moving at the same speed, but the tractor is way bigger, so it has much more kinetic energy. Even if Moby was skiing as fast as he could, he would still have less kinetic energy because the tractor is so massive. Two snow tractors are a different story. Tractor number 1 is moving at 40 kilometers per hour, and tractor number 2 is moving at 30 kilometers per hour. Tractor number 1 has the greater speed, and that means more kinetic energy. Another cool thing about kinetic energy is that it can be transferred from one object to another when the objects collide. Moby's bowling ball only hit one pin, but they all fell down. The kinetic energy transferred from the ball to the pin that was struck and to all the other pins in a domino effect. What's kinetic energy good for? Well, besides being the reason why even you can bowl a strike, kinetic energy can be transformed to give us electricity. This dam makes electricity using running water. Moving water spins the generator's turbines, turning kinetic energy into electricity. Well, technically speaking, energy doesn't really run out. Energy is transferred and stored, but it can't be created or destroyed. All of the energy in the universe is here today. What? No, I don't think you should do that. Okay, I think it's time to use up some of our potential energy to create some kinetic energy and run away.
All right.
Oh.
So,
So,
mute your mic, please.
I think the end was
The end was what?
funny.
Good. And yeah, it might not be letting you type yet, guys, because I have to show you how to type into it. So wait until we get to that part before you start trying to do the lesson, okay? So, that was our information on kinetic energy. So that was all of the energy you get from movement. So energy can be transferred from one moving thing to another one, but it's energy from movement. So now we're going to go back to our PowerPoint and talk about potential energy, because it's a different type of energy now. Potential energy is energy that is not causing any changes now, but it could cause changes in the future. So that basically means that when you're not moving, your body and other objects are storing the energy because it's just chilling and it has the potential to move eventually. So right now, most of you guys are probably just sitting somewhere, correct? So what you're doing right now is creating potential energy and storing up energy in your body so that you can move later. Another reason why we eat food and stuff like that. Okay?
Like magnets?
Kind of. Yeah, magnets have a bit of potential energy in them. And then when you put them closer together, kinetic energy, because they'll go away from each other if they're on the opposite sides. Okay. Our next part. One type of potential energy is gravitational potential energy, which means basically gravity. Gravity is potential energy. It's always there, and it's always like just hanging in the air. So basically it's saying that a metal ball is hanging from a string, and it's not causing any changes right now. So if we just had a ball hanging right in front of us, it's not causing any changes. But when it falls, it's going to cause changes to the clay that it hits, which we don't have clay, but whatever ground it hits, probably going to make a dent depending on how big the ball is. So the higher or heavier, so the more mass that the ball has, the more it will change the clay. So it's assuming that we have a metal ball and a chunk of clay underneath it. And if we drop the ball, it's going to create a dent in the clay. So the potential energy it has is up here while it's hanging. And then once it gets dropped and it falls, that's the kinetic energy. And then it transfers its energy into the clay to change the clay. Okay?
Did he step in the poop?
Whoever that is needs to mute. Alrighty. Next part. Okay, well, again, the higher or heavier an object is, the more potential energy it has. So an airplane, that's way up in the air, right? It has way more potential energy than us sitting on the ground, okay? Next part. Potential energy will eventually transform into kinetic energy. So everything starts as potential energy because it has the potential to do something. It's just how it gets transformed into kinetic energy that is different. So our pencil, so right now, I mean, I have to hold it up to see it, but right now my pencil has potential energy because it's not doing anything. But when I start to move it and put it to a piece of paper, it's transferred to kinetic energy so that I can write. Okay? Anytime your car is just sitting there on its own, it's not on, it has potential energy, and then when you turn it on and start driving, it gets transformed into kinetic energy. Is that making a little bit of sense?
Yep.
Good. All right. So let's take a closer look. The car has the most potential energy at the top of a track. So Lightning McQueen here. Then a small amount of potential energy is transferred into kinetic energy, and the car starts to move slowly. About here on the track, the car has kinetic energy because it's going down the track. It's moving. And
It's
then,
gonna go shoot.
okay, mute please, thank you. And then when it starts to go through this loop-de-loop, it has some of the kinetic energy gets changed back to potential energy. And then finally, at the end, the car continues to change some of that kinetic energy into sound energy and then thermal energy, and then the car slows down. Because sound energy is the sound that the car gives off. Thermal energy is the heat that it gives off. Okay?
Like a drum?
Yeah, a drum gives off sound energy. Yeah. Okay. Next slide. Oh, we have another video. I think it's brain pop again. Okay. Yep. All right, so go ahead and mute again. Please go ahead and mute for me. And then we will watch this potential energy video. Phil, yeah, sometimes depending on the time in high school, you might do like a physics project about gravity in high school. It's possible. It depends on the teacher. That's true. Okay. Oh, there we go. Alrighty. So let's go ahead and watch the potential energy video. Oops. Okay, potential energy. Here we go. Closed captions.
Dear Tim and Moby, when does something have potential energy? From Miley. Well, that jar had potential energy before Moby knocked it over. Gravity pulled the jar down, and energy was transferred when the jar hit the floor. Good question, Moby. Where did the energy come from? Potential energy is stored energy that an object has because of its position or condition. It's related to kinetic energy, which is the energy that an object has because of its motion. The simple difference between the two is that only moving objects have kinetic energy. The pendulum in a clock is a good way to see how kinetic and potential energy work. I'm raising the pendulum above its normal position. That gives it stored potential energy. When I let it go, that potential energy is released and transformed into kinetic energy. As it swings up again, that kinetic energy becomes potential energy. Let's look at it a different way. When Moby and I ride up a ski lift, our potential energy increases as we climb higher. On top of a mountain, we have a whole lot of potential energy, even though we're standing still. That energy represents our potential to move. When you raise something above its original position, it has the ability to fall because of gravity. Right. What goes up must come down, or at least can come down. As I ski down the slope, I'm using up the potential energy given to me by the ski lift. Right again. My potential energy changes to kinetic energy. The more massive an object is, the more potential energy it will have. Because the giant snowball has more mass than Moby, it also has more potential energy. The height of an object plays a role in its potential energy too. Just like Moby and I had the most potential energy at the top of that hill, the higher something goes, the more potential energy it has. Now you've got it. When an object has the potential for movement, it has potential energy. The potential energy is converted to kinetic energy as the object falls. Potential, kinetic.
Tim, what are you boys doing with my mason jar collection?
Nothing, Dad.
Alrighty. I think that's actually the end of the PowerPoint. Oh, there's closure. So, potential energy is when something is sitting still and has the potential to move eventually. Whether someone pushes it, whether you move, whether it's suddenly moved by the wind, whatever it is has potential energy and it's storing up the energy. And then as soon as it moves, it gets transferred to kinetic energy, energy that comes from movement. Does that make sense? Seeing the difference there?
Yeah. Mm-hmm.
Good. Okay, let's look at the last slide of this PowerPoint. Let's see.
What's closure?
Oh, we're going to do this actually on our thing, so never mind. Okay. So a couple of you guys have already tried to start it and said, I can't type. That's because we have to create text box. So we need to go to our Google Classroom. It should be open because you guys got there through to our meet through that. So in Google Classroom, we have a new assignment under science that is called Potential versus Kinetic Energy Compare/Contrast. So you'll open that up, and there's two things attached there. One is the PowerPoint that I just showed you, so you can open that up if you'd like to. And then the other one is a Google slide. Open up the Google Slides so that you see this. And it should let everybody open it. Almost, maybe not Phil at this point. Anyone in it can edit. Okay, so everybody should be able to open it and type in it when we make text boxes. Okay. When you get it open and stuff, go ahead and click done in the chat so that I know. Okay.
That was so confusing, but I don't got it.
Go to Google Classroom. Okay. And open up the potential versus kinetic energy and open up the Google slide that I have as the assignment.
Okay, I'm on there.
Okay, and then just sit tight for a minute until more people are on, okay?
Okay.
I'm going to check the attendance really quick while you guys get that open.
Okay.
Okay, thanks. A lot of you guys here today, almost everybody.
He's absent.
Just the people that have just been having trouble in general getting onto Google and stuff like that. But there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There's 19 of you guys here right now, which is, I think, might be the most that we've ever had on these. That's awesome, guys. I know other classrooms are getting like 12 to 15 of their students on. So I'm glad that we're getting most of our kids on. It's awesome. So we have that pulled up, correct? Got our Google slide. We're all good?
No.
Ready for the next part? Well, you just told me you did, Yoshi.
No, I didn't.
I thought that was you.
Oh, I got it pulled up, but not the text box thing.
Oh, well, that's, we're getting there, but yeah, we have 22, but that's because Mr. Turner is usually on here too. And then don't count me as one of the students. So sometimes we have 22 kids, but that's because sometimes there's 2 of me because I'm presenting my screen. So that adds an extra person. And then sometimes Mr. Turner is here. So usually about 18 or 19 of you guys are showing up. Okay? So let's look at our Google slide. In order to write in here, right, because we can't type in it at all yet, what you need to do is add a text box. So what you do is you go to the top and where it says insert, you click on it. And then the second one down says text box. If you click on that, you can draw a text box in there and start typing.
Does it have to be like a super big one?
Nope, just so that you can type 1, 2, 3, and 4 in it so that you can type the 4 things that you need to do.
Okay.
Okay. So we're going to make one text box on the left side for potential energy. Then we're going to create another text box on the right side for kinetic energy. And then we're going to create one in the middle where the circles overlap. One last text box in the middle, and then we just need 1 and 2 in that one. Okay, so when you're done, you should have 3 places that you can type into.
On both of them?
You need 3 text boxes. One so that you can write 4 differences about potential energy. One so that you can write 4 differences about kinetic energy. And one in the middle to write 2 similarities. Okay? Okay, so go ahead and do that.
I got it.
All right, when you're done, put it in the chat so I know we're ready to move on.
Can we stay on?
Well, I didn't say leave yet,
It's
so yeah,
still loading.
that's fine. Just let it load. As long as you know what you need to be doing, you're okay. Because I'm not going to type anything else for you guys. The rest of it's going to be up to you. I'm just going to explain a little bit more. It's not letting you put a text box down? No? Do you have the circle highlighted like I do right now? Like, did you click on the circle?
I can't type, Miss Jones.
I clicked in the middle of it.
Clicked in the middle of it. Okay, so when you, is it not highlighted, but is it outlined by a box like mine is right now?
Yeah.
Okay, so click on the outside of it and then do the insert text box so that so that it's not highlighted, and let me know if that works.
Okay.
How many do we have to put?
My mom just texted. Oh, sorry.
You need 4. So 3 text boxes. The one in potential energy has 4, like 1, 2, 3, and 4. The one in,
Because I thought we had to do like 1 to 1 or 4.
we only need 1
Or
text
3.
box.
Do you pick
Because
2 in the middle?
No, just 1 in the middle. Well, 1 text box. The numbers 1 and 2.
That's it for the middle ones, just 2?
Yep.
Okay.
Dallin, did you get it to work? Okay. All right. So what you guys are going to do, you have the PowerPoint on your Google Classroom right there. You can open it up and use it, and I would highly suggest that you do. But your guys' goal here is to complete this Venn diagram. So remember, Venn diagrams are showing me how, like, things that are similar in the middle where the two circles overlap. So you're going to tell me two similarities in the middle between potential and kinetic energy. Okay? And it can be as simple as they're both energy. You can steal that one if you'd like to. It can be as simple as that, or you can get complex if you'd like to. But you need two similarities, two things that are the same about potential and kinetic energy. On the left, where it just says potential energy, you need to have 4 things that are different than kinetic energy. So 4 differences for potential energy. And then on the right, you're going to do the same thing, 4 differences for kinetic energy. So altogether, you need to find 10 facts about these two types of energies, and there should be enough in your PowerPoints to do that. And then when you're done, you're going to hit turn in, which should be on the right side of your thing. But I am going to grade this out of 10 points. You need to make sure you have all 10. Sound good?
Am I supposed to have 1, 2, and 3, and 4?
No, you have to create those text boxes. That's what we just spent some time doing. Okay. All right. Do you guys have any questions about what you need to do for that?
Okay.
No, you guys good? Okay, so it's 1:11. I would like you guys to stay on for 10 minutes. So let's say 1:20. I'll have you guys stay on for 10 minutes to work on it. So if you have any questions, you can ask me. After those 10 minutes, I'll let you guys head out for the day. Sound good? Okay, this is going to be a graded assignment, so make sure that you are completing it, especially if I'm giving you time right now.